right? So we'll solve some of the problems based on this understanding. Note down one problem. A heavy particle hanging vertically from a point by a light inextensible string. By a light inextensible string of length L is started so as to make a complete revolution in a vertical plane. Prove that the sum of the tensions at the end of the sum of the tensions at the end of any diameter is constant. Can you try to solve this problem? Okay, so let me solve this. So a heavy particle hanging vertically from a point. That means, so this is the point and this is the location of the particle, and it started rotating in a vertical circle like this. So it started rotating in a vertical circle. Now actually, whenever the particle started moving, let us say if you consider this location, then actually there will be an associated tension on this particular line. So this is the thread. Now if you take the opposite side, this will be the other extreme of the diameter. Now at the other extreme of the diameter, so let us say if it is making an angle of theta, obviously this angle is going to be pi plus theta, right? Now there what happens is, what he asked us to prove is, so from a point by a light inextensible string of length L, so this length is L, he started so as to make a complete revolution in a vertical plane. Prove that the sum of the tensions at the end of any diameter. So the sum of the tension, here actually if I call it as T1 and here it is T2, then T1 plus T2 I need to prove that it is going to be a constant. So the tension at any instant, so tension of a string is equal to m by a times of u square minus 2az plus 3az cos theta is the tension of the string at any instant for any particle which is moving in a circular fashion. Now u square minus 2az plus 3az cos theta. Now if this is angle theta, then actually T1 is going to be the same, but T2 is going to be 180 plus theta. So m by a times of u square minus 2ag plus 3ag cos of 180 minus plus theta. So cos 180 plus theta is going to be minus theta. So m by a times of u square minus 2ag plus, so plus becomes minus now 3ag cos theta. Now if you add these two together, t1 plus t2 equal to m by a times of u square minus 2ag. So this is going to be 2 times. Now, so this one, whatever it is there on the right side is a constant, because it's no way dependent on the angle or independent of theta. So this is independent of theta. Got it? Understood? Okay, so you can note down this. Note down one more. A particle makes complete revolution complete revolutions in a vertical circle. If omega 1 and omega 2 be the greatest and least, if omega 1 and omega 2 be the greatest and least angular velocities and R1 and R2 the greatest and least reactions, R1 and R2 be the greatest and least prove that least reactions prove that when the particle projected from the lowest point particle projected from the lowest point of the circle makes an angle theta at the center, its angular velocity is square root of omega 1 square cos square theta by 2 plus omega 2 square sin square theta by 2. So this is what we need to prove. And one more, and that the reaction is T equal to or R equal to R1 cos square theta by 2 plus R2 sin square theta by 2. Can you try to prove this? Okay, so let me solve this. So the first one, the particle makes makes complete revolutions in a vertical circle if omega 1 and omega 2 be the greatest and least angular velocities. Now the greatest and least angular velocities comes from the fact that, so this is v square is equal to u square minus 2ag plus 2ag cos theta. So this is the velocity, and this is the peripheral velocity or the linear velocity. So the relation between the angular velocity and the peripheral velocity is going to be, so v is equal to a times of omega. So this is the relation in any circular motion. Now if I replace this one, a omega whole square equal to u square minus 2ag plus 2ag cos theta. Now omega square is proportional to the right side part of it. Now here the angle theta will decide where we can get the maximum angular velocity or the minimum angular velocity. Suppose if cos theta equal to plus 1, then actually we are going to get the maximum angular velocity. That means at cos theta equal to 1, we get maximum angular velocity. And cos theta equal to minus 1, we get least angular velocity. So the greatest angular velocity, so angular velocity, omega 1 and omega 2 be the greatest and least. So the greatest angular velocity is, this is omega 1 and this is omega 2. So omega 1 we can get if cos theta is replaced with 1. So then it is going to be a square omega square is equal to u square minus 2ag plus 2ag. So this 2ag will cancel out, and this is going to be omega 1, and so a square omega 1 square is equal to u square. So this is equation number 1. And then the least angular velocity we are going to get when cos theta equal to minus 1. So if I replace with minus 1, so this is going to be u square minus 4ag, that is a square omega 2 square is equal to u square minus 4ag. So this is the least angular velocity omega 2. So we have got two different equations. From this actually we can solve for u square and ag value. Then actually at any angle which was given randomly, let us say theta, there we are going to get the angular velocity from the same relation by substituting the value of omega 1 and omega 2 instead of u square and 2ag. Got it? Okay, first you note down this, we are going to do that. So we have got a square omega 1 square is equal to u square, and if I substitute here in this equation, then actually we are going to get a square omega 2 square is equal to a square omega 1 square minus 4ag, or 4ag equal to a square omega 1 square minus a square omega 2 square. So this is the third equation which we can get the relation for ag, right? Now we have got the fundamental relation v square is equal to a square omega square is equal to u square minus 2ag plus 2ag cos theta. Now if I replace this 4AG, I call this as 2AG and I divide here with 2 so that I can straight away substitute there. So A square omega square is equal to U square, I can replace with A square omega 1 square minus 2AG. If I take out 1 minus cos theta will be left over. So this is A square omega 1 square minus 2AG, I can replace as A square omega 1 square minus A square omega 2 square by 2, getting multiplied by 1 minus cos theta is sin square theta by 2. 2 times of. So this 2 will cancel out. So A square omega 1 square minus A square omega 1 square sin square theta by 2 plus A square omega 2 square sin square theta by 2. So this is A square omega 1 square 1 minus sin square theta by 2 plus A square omega 2 square sin square theta by 2. So this is going to be A square omega 1 square cos square theta by 2 plus A square omega 2 square sin square theta by 2. So this is A square omega square. This A square will cancel out and omega is going to be square root of omega 1 square cos square theta by 2 plus omega 2 square sin square theta by 2. So this will be the relation. Got it? Now exactly in the similar lines, we have got the relation for the reaction. So reaction is equal to m by a times of u square minus 2ag plus 3ag cos theta. So this is the relation for the reaction in a constrained motion which is moving in a vertical circle. Now with that relation, exactly in the similar procedure, you try to adapt and then try to prove the relation. So the same procedure, solve for u and ag and resubstitute back. Can you try to solve that now? You can note down this. So we have got two different relations for the reaction as well. So reaction R1. So R actually, this is the relation. Now at cos theta equal to plus 1, maximum reaction. And this is what we call as R1. And cos theta equal to minus 1, minimum reaction. And this is what we call as R2. So if you get the relations, R1 is equal to m by a times of u square minus 2ag plus 3ag. So this is AR1 equal to mu square plus mag. This is equation number 1. And then the second relation is R2 equal to m by a times of u square minus 2ag minus 3ag, because cos theta is minus 1. So this is AR2 equal to mu square minus 5mag. This is equation number 2. So if you solve these two relations, then first you subtract it. AR1 minus AR2 is equal to 6 mag. So this is equation number 3. So similarly, if you substitute the 6 mag in any of the relation, then suppose if I take it in the relation number 1, AR1 equal to mu square plus AR1 minus AR2 by 6. So this if you simplify it, so mu square is equal to AR1 minus AR1 by 6 plus AR2 by 6. So this if you simplify it, 5AR1 by 6 plus AR2 whole divided by 6. So this is mu square value. So we have got two different relations. So this is equation number 6 and equation number 7. So these are important for us. So I'll just note down those relations here. Those relations are AR1 minus AR2 is equal to 6 MAG. This is one relation, and this is equation number 3. And another relation is mu square is equal to 5AR1 plus AR2 whole divided by 6. So this is equation number 7. So these relations we can make use. First you note down this. We are going to use that relation to get the general value of r at any instant of theta. Done? So once we got these values, so from the first relation r is equal to, so from this relation you can write that AR for any random angle of theta mu square minus MAG so AR is equal to mu square minus 2 MAG plus 3 MAG cos theta. So if you substitute those relations, mu square I can replace with AR is equal to 5AR1 plus AR2 by 6 minus MAG. If you take it out, then actually you can write AR1 minus AR2 by 3. So that 2 MAG is equal, and plus AR1 minus AR2 by 2, which is equal to 3 MAG into cos theta. So if you further simplify this, AR is equal to 5AR1 divided by 6 plus AR2 divided by 6 minus AR1 by 3 plus AR2 by 3 plus AR1 cos theta by 2 minus AR2 by 6 by 2 into cos theta. So if you write R1 part separately, so this one and this one and this one. So 5AR1 minus 2AR1 plus 3AR1 cos theta whole divided by 6 plus AR2 plus 2AR2 minus 3AR2 cos theta whole divided by 6. So this is simplified to 5 minus 2 is 3, 3AR1 into 1 plus cos theta by 6 plus 3AR2, if you take out 1 minus cos theta by 6. Now from this actually, this can be written as 6AR1, 1 plus cos theta is 2 cos square theta by 2, in that 2 I have already multiplied. So cos square theta by 2 by 6 plus 6AR2 sin square theta by 2 divided by 6. So this 6 will cancel, and then finally what we left is the answer. R is equal to AR1 cos square theta by 2 plus AR2 sin square theta by 2. So this is the answer. Got it? So this is how actually you will be playing with the fundamental relation of the reaction or the tension, or it may be the velocity relation. So nothing more than that. So in whatever may be the case, actually it will always be exactly in the similar manner. Only thing is you should be analyzing those equations. Clear? Any questions on this? Any questions? Okay. So note down one last question. A particle inside and at the lowest point of a fixed smooth hollow sphere, a particle inside and at the lowest point, inside and at the lowest point of a fixed smooth hollow sphere of radius A is projected horizontally, of radius A is projected horizontally with velocity square root of 7 ag by 2, with velocity square root of 7 ag by 2. Show that it will leave the sphere, show that it will leave the sphere at a height 3a by 2 at a height 3a by 2 above the lowest point and its subsequent path meets the sphere again at the point of projection. So here, see this, what happens is, this is a sphere. Now, so a particle inside at the lowest point of a fixed smooth hollow sphere of radius A projected horizontally with velocity square root of 7 ag. That means the particle is here. Now actually this was projected by giving an initial velocity of u, which is equal to u square is equal to 7 ag by 2. So this was the initial velocity what it was given. Now it will try to go in this particular path automatically because it is constrained to move only in the spherical fashion. Now show that it will have, so it will leave the sphere at a height 3a by 2 above the lowest point and its subsequent path meets the sphere again at the point of projection. That means, so when it is projected in this manner, so it may not complete the complete circle because this velocities may not be sufficient. If you notice, 5 ag is the required velocity to make a complete revolution for any spherical shape. Now here 7 ag by 2 is nothing but 3.5 times of ag, which is lesser than 5 ag. Hence, it will leave the sphere somewhere, and it is going to leave only after the 90 degrees. That means maybe somewhere here what happens is the velocity is not, so the tension becomes 0 and the velocity subsequently it comes here and then actually leaves the path like this. Now in the subsequent statement what he said was, when it is leaving the particle like this, it will go and meet the projected point again. So that is the problem statement. So it may go this way, or it may fall down like this, or it may fall like this, or it may come to this location, depending upon the velocity at this particular location. Now where it is going to live? Where the tension becomes 0. If the tension becomes 0 or the reaction becomes 0, there actually the particle will no more stick to the sphere, it will leave the sphere where the reaction becomes 0. So this is the place, let us say the reaction becomes 0, and that possibility can happen only between the angle of 90 degrees to 180 degrees. So if you count the angle from here, 90 degrees to 180 degrees is the place where there is a possibility of falling down, or where there is a possibility of R can become 0. So there it is going to leave. Now when it is leaving the particle, so it may have certain velocity. Now let us find out where it is going to leave. So the fundamental relation is R is equal to m by a times of u square minus 2ag plus 3ag cos theta. Now when the reaction becomes 0, this is going to be 0, and u square value which was given as 7ag by 2. So m by a times of 7ag by 2 minus 2ag plus 3ag cos theta is equal to 0. From this relation, 7 by 2 minus 2 is going to be 1.5. So 3 by 2 times of ag plus 3ag equal to 0. Now this 3 also will cancel out, and then so cos theta will be there. So this ag also will cancel out, and from here cos theta is going to be minus 1 by 2. It has to be a negative value because the angle can be only above the 90 degrees and below the 180 degrees. Hence, so this has to be a negative value where cos can be negative after 90 degrees. So the theta is, only possibility is 2 pi by 3. So which is 120 degrees from the point of projection. So this is leaving the particle. So this is leaving the surface at an angle of 2 pi by 3. Now here actually it is leaving. So there actually what he said was, so it leaves at a height of 3a by 2. So this angle is 120 degrees. If this angle is 90 degrees, then the height from the point of projection is going to be this one, till this point from this particular bottom. So till this point it is a, and this is a, and this angle is going to be, till this point it is 90 degrees, and then this is 30 degrees. If this is 30 degrees, and then this angle is going to be 30 degrees, and this angle is going to be 60 degrees, then a cos 60. So this height is going to be a cos 60 is nothing but a by 2. Till this point it is a, and till this point it is a by 2. The total height from the bottom where it is leaving the sphere is going to be 3a by 2. So that you can straight away get even mathematically without analyzing that. So the height at which the particle leaves the sphere. So this is going to be h is equal to a minus a cos theta, where theta is 120 degrees for us. So a minus a cos 120. So this is going to be 3a by 2. Got it? So the first case is proved, where the particle is moving out of the sphere at a height of 3a by 2, which is at an angle of 120 degrees from the initial line of the vertical. Got it? Note down this. Now, when the particle is leaving the sphere, which angle is not understood. So this angle is actually, we calculated actually when cos theta is equal to 120 degrees, sorry, when theta equal to 120 degrees, this is leaving, because actually we calculated that cos theta is going to be minus 1 by 2 is the place where r can become 0. So from there actually we have got the 120 degrees. Now from here it is 120 degrees, and we know that actually for the horizontal line it will make an angle of 90 degrees. Then 120 degrees can happen only after 90 degrees for an angle of 30 degrees. So this angle is going to be 30 degrees, and then obviously the parallel line. So this is one line and this is one line, and if it makes 30 degrees here, here it will be 30 degrees. Now if you draw a vertical line, this is going to be 60 degrees. So this is what I have written here. Got it? I have not used anyway. So I have written everything clearly but not used it. Now actually, so we need to use that as well. See this. Now when the reaction becomes 0, r equal to 0 at cos theta equal to minus 1 by 2. Now there the velocity, it may 0 or it may not be 0, but it will definitely be not 0, because in yesterday's class I proved that this can be 0 only at an angle theta equal to 90 degrees. Now the angle is 120 degrees. Then definitely there will be an associated velocity though the tension becomes 0. So that velocity is going to be v square is equal to u square minus 2ag plus 2ag cos theta, where cos theta equal to minus 1 by 2. So this is u square minus 2ag plus 2ag into minus 1 by 2. So 2 will cancel out, and then u square minus 3ag, and u square value is going to be 7ag by 2 minus 3ag. So this is ag by 2 is the v square value. So it is projected with a velocity which is equal to square root of ag by 2, and this is projected here with a velocity which is given as v is equal to ag by 2 under root. And if you notice, this is going to be a tangential velocity, because this is always projected in a tangential direction. So if it is projected in tangential direction, then it is making an angle of alpha. So this angle is the alpha for the projectile, where it is trying to leave and then actually take this particular path of the projectile. And this is projected in this direction with an angle of alpha, which can be calculated from this relation now. See this, this is the horizontal line and this is the radius, and we know that this angle is going to be 30 degrees, because actually till this point if it is 120, obviously for the horizontal line it is 30 degrees and alternate angle is going to be 30 degrees, and we know that this radius and this tangent is going to be at an angle of 90 degrees. So if this is 90 degrees, then this is 30 degrees, hence this alpha, the only possible value of alpha is going to be a 60 degrees. Got it? So because this angle is 90 degrees and this angle is 30 degrees, and this can be only possible if it is 60 degrees. So that 60 degrees, this is the projected angle. Now the path of the projectile, we know that y is going to be x tan alpha minus gx square by 2u square cos square alpha, where u is the velocity of projection. And here in this case it is going to be v. So v is the velocity of projection is going to be ag by 2 under root. Now taking that relation, and alpha is going to be 60 degrees from the diagram. Now with this understanding, if you find out the projectile equation, y is going to be x into tan 60 minus gx square by 2u square is going to be ag by 2 into cos square 60 degrees. So this can be x root 3 or root 3x minus gx square by 2az by 2 into cos 60 is 1 by 2. 1 by 2 whole square is 1 by 4. So 2 will cancel out and this 4 comes out root 3x minus 4gx square. So this is the equation of the projectile. So we have got the equation of the projectile. Now actually we have to prove that this projectile, whatever it is projected here, it is going to pass through this particular minimum point. See this, Pankaj, see this is the radius and this is the tangent, and the angle between the radius and tangent is always going to be 90 degrees. And then this angle, so this is making an angle of 30 degrees to the horizontal line. Now if this is 30 degrees, then actually I have drawn a line like this which is parallel to this line, it is going to be 30 degrees. So if this is 30 degrees and this angle is 90 degrees, then this is going to be 60 degrees. I hope you understood now. Understood? So what is the second part? So you understood this is 30 degrees, right? So if this is 30 degrees, then the alternate angle for the parallel line, it is going to be 30 degrees, and this is the tangent line and this is the radius line. So this radius and tangent will always be at 90 degrees in any circle. Now hence, so this horizontal line is making 30 degrees. Obviously it can make only 60 degrees, then only the sum will be 90 degrees. Why parabola only? Did you not attend my class of projectiles? See this. This has to be a parabola because the path of the projectile in any case is going to be a parabola. So you try to watch the recording of my previous classes where I have clearly explained why it is going to be a parabola. Got it? Okay. So note it down. And then from here actually, so root 3x minus 4gx square equal to y is the equation of the projectile. Now this equation of the projectile has to pass through this minimum point. Now this is the origin point for us, and let us say this is the positive x direction where I have taken in the left direction as the positive x direction, and the vertical position from here is going to be the y direction, and then the path of the projectile is tracing in this direction so that our equations won't change in the projectile analysis. Now if it has to pass through this point, and this is at a point from this horizontal line at a point given by minus 3a by 2, because this height actually we already calculated, it has to be 3a by 2. Then the coordinate of this particular point is going to be minus 3a by 2. So it is minus 3a by 2, and then this point at a horizontal length of this length which we need to calculate, and this is being a and this is making an angle of 30 degrees to the horizontal, then a cos 30 is the x coordinate here. So a cos 30 is root 3 a by 2 is the x coordinate. Obviously this coordinates when I calculate as if like it is a projectile, then root 3 a by 2 comma minus 3a by 2 is the point where it has to pass through, which is the minimum most point when compared to the coordinate system what I assume to be at this particular point as the origin. This is positive y direction and this is positive x direction, and this is the location of the point where it is located at a root 3a by 2 comma minus 3a by 2. So this point has to be satisfied by this equation so that I can assure that this projectile is passing through this particular point. Now there, so if I substitute the x value, I can get the value of y. So x value is going to be this length in the positive direction of x. So this length, this is at a and this is making an angle of 30 degrees. Hence a cos 30 is root 3 a by 2. If I substitute here, so y is going to be root 3 times of root 3 a by 2 minus 4g into 3a square by 4. So this 4 will cancel, and this is 3a by 2, this g coming extra somewhere. Oh, so I have not cancelled g value here. Yeah. So g will cancel, and here 4x square is going to be. Yeah. So 4x square now minus 3a square. So this is going to be minus 3a by 2. So when I substitute x is equal to root 3a by 2, then we have got the value of y, which is equal to minus 3a by 2, which is the coordinate of this minimum most point of this particular sphere. Got it? Understood? Yeah, Pankaj, do you still have question on this projectile? I hope rest of the people understood. Okay, so why it has to be parabola? The path of the projectile is always a parabola, because actually the equation we proved it is going to be coming in this particular format. Even here also actually it is coming in this particular format. Any equation of this form is a parabola. So this can be expressed as if like x minus h whole square is equal to some constant 4a into y. This format actually you can express this equation. So any equation which is a quadratic on left side and the right side is going to be a power 1, then it is going to be a parabola. So here actually x minus h whole square is equal to 4ax, 4ay is going to be a parabola, and the projectile actually, which is the equation of the projectile for any random projection at an angle of alpha, is coming out to in this particular format of ax plus bx square equal to y, which is going to be a parabola equation. Hence, we analyzed as if like it is a parabola. Got it? So that is for the namesake I am saying it is parabola. Even whether we know it is a parabola or not, it won't make any sense for our analysis. Got it? Okay, so any questions, anybody? See this, why it is going to be parabola at this location is, when the particle actually when it is projected from here, so this is trying to travel in this particular path. If the velocity is sufficient, what is happening is, when it is trying to travel in this location, at this location the reaction becomes 0. If the reaction becomes 0, then actually it will be falling down automatically. But to fall down straight away, it has to fall down like this. But it won't happen that way, because though the reaction is becoming 0, this is still have a tangential velocity of magnitude square root of ag by 2. Hence, this is as if like it is a projectile, it will try to leave the body. Got it? Maybe that could be your question, right? So this will be leaving as if like it is a parabola, so that as if like it is a projectile. Hence, actually it is coming on taking the projectile path. Yeah. Got it? So, Vishal, so this is the y value, this is going to minus 3a by 2. Where is the mistake? So this g value actually I ignored initially, so I counted, and then actually finally coming out to be root 3x minus 4x square is equal to y. So this is the equation. If you substitute x is equal to root 3a by 2, then actually it is going to be y is equal to minus 3a by 2, which will be the coordinate of this location from this coordinate system. Got it? So this equation I will write clearly, x into root 3 minus gx square divided by 2 times of u square value is going to be ag by 2, and then cos square 60. Cos square 60 I can write as 1 by 4. Now this 2 will cancel out, and then g will cancel out. Yeah, it's correct. So this is A. Right, so G will cancel out, and then this 4 comes up, and then in the denominator A is left over. So root 3x minus 4x square by A is equal to y, and then when you substitute here, so y is equal to root 3 times of root 3a by 2 minus 4 times of a square by 4a. Got it? So this a will cancel out, and then 3a by 2. Now it is correct. Yeah. Got it? Yeah, thank you. So do you have any questions on this? So with this, we can conclude this constrained motion. So in the next class, actually, Monday I am going to take up the class again. So there actually I am going to start with the Kepler's laws. Got it? So with after the Kepler's laws, we left with only one part, that is motion under central forces. So with that we will be done. Work, power, energy anyway is part of that part. Got it? Yeah. So that's all for today. Thank you. So tomorrow no class.